everyone.
Hey everyone.
Hey everyone.
Joining us today is Dr. Lydia Contreras, professor at the University of Texas at Austin's Department of Chemical Engineering.
Speaking with us today is Professor Bashima Islam from the Department of Electrical and Computer Engineering at the Worcester Polytechnic Institute.
And speaking with us today is Dr. Ritendra Datta, Director of Engineering at Meta, who completed his PhD degree from Penn State.
My lab works on the area of synthetic biology, and we combine a number of tools, including machine learning tools, so that we can learn a bit more and engineer RNAs. So one of the things that chemical engineers have been very active on, it's in the biotechnology industry and applications. And this field really started with the ideas that cells, so bacterial cells, human cells, eukaryote cells, can be used as factories that can be controlled and directed to make any molecules that we desire.
The bigger aspect of my research is to focus on ubiquitous and mobile computing that includes Internet of Things or IoT, where the goal is how can we use the everyday objects around us for the betterment or development of ourselves, our environment, and our society.
My area of research was machine learning, computer vision, a little bit of information retrieval. All of these are, I don't know, like it's been more than a decade since I did my PhD, and all of those topics are still super relevant.
When I was growing up, I still remember I had a lot of interest in medicine. I wanted to be a doctor, a medical doctor. And I think that part of that is because that's what I knew. You grew up going to the hospital, seeing doctors, seeing what they did. When you thought about engineering, my vision of an engineering, the only type of engineering that I knew at the time was civil engineers, because I could see bridges, right? I could see bridges, or mechanical engineers. I can see plane designs. I heard of NASA going to space and what they did to design those space shuttles, etc. But I really became fascinated in high school. When I was going in high school, this is where the Genome Project was going on. So people were really, for the first time, discovering all the genetic sequences that made up a human being. And it was fascinating. And I remember being caught up in this idea that if we know what makes a human being, we can actually synthesize things. We can synthesize biology to do really powerful things in society. So I remember that, and I became really interested in that concept very early on.
And started writing code when I was, I think like 10 or 11 years old. And then I found that I was in middle school and high school, my popularity was a function of how cool of a computer graphics program I could write. And so that sort of gave me motivation to write more computer graphics programs. I wrote a bunch of very interesting computer applications. Like I wrote a chess program. I think I wrote an early version of sort of Google Maps for a city in India before Google Maps was a thing. So I dabbled with a lot of that stuff. And then when I came to grad school, I realized that, yeah, all that's fine and it's cool and it's fun to, get a lot of appreciation from friends and parents and so on. But really what I figured out was that the world is moving toward higher volumes of data. Every system out there is collecting so much data that making sense of that data is going to be the problem of the next 3 decades. And so I actually switched from just doing cool programming because it made me popular with my friends to what I felt was the most important problem to solve. And so I switched from computer graphics and some other areas that I initially thought I'd work on to statistical modeling and machine learning, because ultimately being able to make sense and to be able to predict the future using data is going to be a very compelling theme. And I sort of was lucky enough to figure that out 15 years back, and like 15 years forward, we are still trying to figure that out.